Hi, and welcome to Maths Appeal. I'm Bobby Seagull.
And I'm Susan Okereke.
We are two maths teachers who think that maths is cool, and we would love to show you that maths is cool as we think it is as well.
We at Maths Appeal, we love to get people involved. We want to make maths more accessible to people. We want to encourage people to do problems, and that's why we do Maths Appeal.
So actually this series, against our second series, it's all been about problem solving and mathematical thinking. So just a way of almost like a way of life, like approaching problems in a logical mindset. So what we do is every single episode we have a maths question and we work through it together.
We know as teachers it can be a bit difficult to sort of teach problem solving, and we believe the best way to get better at problem solving is to solve problems. And we decided to sort of share a structure of a way of tackling problems. And they're generally about getting people to ask questions to themselves, but we're actually asking them to each other. And we start each problem, before you do any maths, you start to think about what's going on in your mind first. So first question you ask is, how do you feel when you first saw the problem or heard the problem? Does the problem make sense to you? You ask this to yourself. Are there any questions you have about the problem? And then what are the maths topics in the question? So before you do any maths, you're starting to gauge where you're at, how you feel, and what you already know before doing anything.
So then while you're actually doing the problem, some more things to think about. Firstly, are there key facts you can identify from it? Then are there sort of any rules or formulae that you need to know to solve the question? Then finally, are there any sort of facts that you can go through and derive from the actual problem, almost like underlining and saying, oh, I can derive this? And then finally, are you in a position to actually go and tackle the question immediately?
Right, Bobby, are you ready for our problem for this week?
Yes, I am.
I think you're ready now. Listeners, I hope you're ready too. Get yourselves organised, get yourselves ready to tackle the problem, and it will be coming after this.
So the problem for today's episode is scientific or astronomic. So the length of a day on Earth is 24 hours. The length of a day on Mercury is 58 2/3 times the length of a day on Earth. So what is the length of a day on Mercury in hours? So I'll say that one more time. So the length of a day on Earth is 24 hours. The length of a day on Mercury is 58 2/3 times the length of a day on Earth. So what is the length of a day on Mercury in hours?
Hope you're ready. Hope your brain started to work, started to start thinking. And we're going to tackle that problem in just a moment. But first, we are going to talk about a debate that's being hotly discussed in the maths community, and should we rename maths numeracy? Bob, are you going to tell us a bit more about this?
Yes. So, Andy Haldon is a former chief economist of the Bank of England, actually also trustee of national numeracy. And
one of our favourite charities.
Yes, it is. It is.
Yeah.
It's a Maths Appeals, one of our favourite charities, absolutely. And there was headlines in the newspapers, in the Times, in the Daily Mail, in the Metro, and the headline, Susan, said, "Maths called numeracy makes scary economist says." I mean, that's a weird headline, but essentially, I know, that's what it says on the website. But
not great English, mind.
Yeah, I know, but yeah, they need better English. But that was the headline. But essentially, the top line of the discussion was, I'll read this paragraph. It says, the subject of maths should be referred to as numeracy to make it sound less scary and help people budget during the cost of living crisis, a top economist has said. Andy Haldon, formerly Bank of England's chief economist, said that calling the subject numeracy would help people use it in their everyday lives and convey the importance of numbers. Calling it mathematics makes it sound quite conceptual. Some people don't get conceptual stuff. Ooh. Thoughts. Write a 1,000-word essay submitted by tomorrow at 6 o'clock.
Ooh, some people don't get conceptual stuff. I'm not sure I agree with that statement as a maths
teacher. Do you know Andy Haldon, his own story is, obviously this man is a very successful economist, was the chief economist of the Bank of England, and he actually revealed that he didn't actually take A-level maths, can you believe it, for Britain's most senior economist. And the quote is, he had to teach himself A-level math skills one summer before pursuing a degree in economics at the University of Sheffield. So he went into economics without a maths A-level, which is remarkable.
Quite unheard of, yeah, because economics is very maths heavy. But it's obviously Brighton,
Yeah, clearly.
conscientious student to be able to do that, because the discipline you need to be able to do that is not small. So I'd say controversially, I'd say math A level is one of the hardest A levels to get. But I also, it's interesting his idea of that, because concepts, I think people understand concepts when they're explained well to them and they've engaged with what the concept is. And so I don't know if is he talking about abstract mathematics? That's different to concept. That's different. That's like
I think with Andy, he talks a lot about, because I've met him many times. I spent an afternoon having coffee at the Bank of England with him once.
Oh,
amazing
very
office
nice.
he had, and he was talking about how, most people, we're using numbers for our day-to-day life, like looking at interest rates or seeing if we've got a good value in our shopping, all the practical bits. But he said the parts of maths, again, it is the bits that involve algebra and graphs and maybe geometry, the ones that he thinks are not practical numbers based, that scares people. So if we change the subject title, maybe people go, oh, I hated maths, but numeracy, numbers are okay.
So the problem we have, I think, with this statement, so I'm not arguing with him. So I actually think a lot of what he's saying is real. But there's a bigger question. As a teacher in a school, there's a subject of maths, and to rename it, I think, wouldn't work, because it is maths, it's not numeracy. There's another argument of, like, for me, this is my argument that I think
I know what you're going to say. So say it. I'm going to tell you if
you agree.
Yeah.
Okay. So my thing is, I think there should be two courses. One is maths GCSE and one is numeracy GCSE.
Hallelujah. Amen.
Preach, brother.
Preach, sister.
I think we need to think about the subjects as different, because, as you say, like, there are some people who will love doing algebra or will need to do algebra or geometry in more depth for their subjects beyond school. Okay, and they should do maths GCSE and then potentially maths A level. But 100% of people in this country, in the world, let me say it, in the world, need to be like competent and confident in numeracy, which involves looking after your household, being able to work out percentages, being able to know basic measure and convert between them, being able to problem solve with regards to real life things like your mortgage, like, is this a good deal or not? And so renaming it, I think, is not the most useful thing to do. I think there's a massive discussion that should be being had about the qualification that's done in school regarding maths and numeracy for people going into the real world. And a thing I'm putting forward, I think Bobby's already preached, he's like with me with this, is we have two separate subjects, maths and numeracy.
I think, I'm pretty certain, when I've mentioned this topic before to friends, there's some people in Scotland, and they said they used to have something like a maths and an arithmetic subject, like back in the 60s or 70s, and everyone did. Arithmetic wasn't the same as maths, which is more conceptual and abstract, but arithmetic had the practical numeracy, essentially what we talk about. So I genuinely think, maybe Maths Appeal, we should start a campaign. We'd love to hear listeners' thoughts on whether you think there should be almost like a separate GCSE. Exactly what you said. I would completely back it, because everyone would do the numeracy and most people would do the maths. Like if you're someone that's getting a grade 1 or grade 2, which is like one of the lowest grades, maybe maths wouldn't be appropriate, but definitely try and get the numeracy.
Yeah, and maybe it's about thinking about when we offer it. Do we get everyone to do numeracy in year 9? If you haven't got it in year 9, you keep doing it to year 11. Like, I think I do not have we do not have the answers, but we definitely have some questions to think about, like how fit for purpose is maths GCSE. If you think so, what is the purpose of maths GCSE? What's the purpose?
So some people think, is it just to prepare you for A-level maths?
There we go. Is it, or is if 100% of people who are doing it and have to do it, shouldn't it be more about utility and agency, about using maths in the real world? And if that is the case, is what they're learning at GCSE and in year 7 and 8 and 9 and at primary school, is it really equipping them to be competent human beings in the working world with this stuff if they take it only to foundation level? And that's kind of what, because the majority of people do that, you know what I mean? It's kind of what we're thinking there. So I don't know, like, I think it's a great conversation that Andy Haldane has kind of like put out there. I think it's, I think we should be talking about how does this make people feel, but also thinking about what are the practicalities of things regarding how maths is used in the real world and what is numeracy and what is maths. Because can you just change the names? Do they mean the same thing? Do you know what I mean? That's a big question. And I'd also like to think, is it about marketing it differently? Because you can't. I think you can't just change a name. That's like too complicated and difficult. But it's definitely a big discussion that I'd love to, as you said, Bobby, like hear more opinions of other people and also get people further up talking about it. Because I think I regularly have taught year 11 kids, this is for many years, getting ready for the GCSE, and there are just moments when I'm delivering stuff to them, knowing that most of the kids I'm teaching aren't going to take maths A level because I'm teaching foundation students, and there are times when I'm delivering things to them and just going, this is a waste of your time and a waste of mine.
Like I think in foundation GCSE maths, you have to learn by rote certain trigonometric identities. That's in the paper, isn't it? It's a grade 5 question.
Yep.
So you need to learn what sine of 30 is a half, sine of 60 is root 3 on 2. And obviously, as a mathematician, that's really cool, like how you derive it from first principles. But if you're someone that's struggling with arithmetic and numeracy, just learning them off by rote just for one day in June in your GCSE doesn't really serve much of a purpose.
And I think we put that out there, Bobby. That's a bigger question that we'd love to get the world to get, definitely UK, England talking about. So watch this space, yo.
we preach a separate numeracy qualification.
So I think it's time for us to get back to our puzzle. We put a puzzle out there for people in two ways. One is a question and one is a bigger thought process. So can you remind us of what the puzzle is for today that we're going to try and work out?
The puzzle was out of this world. So actually, just to tell you, this problem is from a key stage 2 SATs exam at year 6. So it's something that 11-year-olds throughout the country would have done.
Yeah. So
that's why if you thought, that sounds like maths appeal have made it very accessible today, because we're trying to show maths is for not just GCSE or A-level students, it's for everyone. So it's something which, and again, national numeracy has the stat that 1 in 2 adults has the numeracy of an 11-year-old. So this is actually quite an appropriate question. So the length of a day on Earth is 24 hours. And the length of a day on Mercury is 58 2/3 times the length of a day on Earth. So what is the length of a day on Mercury in hours?
Right.
So, Susan, we know the drill now. So when you first saw the problem, what were your thoughts?
When I first saw this problem, I was like, okay, that's fine. I get it. I know what I need to do. And then I thought to myself, so these are year 7 kids, so they're 11, and they're doing it without a calculator. And then I thought, gosh, this is long. That's what I thought. Because I think that you have to do some calculations like this at secondary school. But in primary school, they're expected to do this pen and paper and not with a calculator, which I think in real life you'd use a calculator for this. So if you did, totally fine. But just think 11-year-old kids are expected to do this without a calculator.
Yes, I guess that's what brings it the additional, the mechanical operational challenge. So did it make sense to you? Did you have any questions that you thought, what's this on about?
For me, it was okay. I think the idea of 58 2/3, I've done this with some teachers before, and I think the fraction part, can sometimes be jarring to some people. I'm hoping when you read it out, people understood what the 2/3 meant as well, because they might not have seen it for a while.
That's a good point. And then what topics immediately screamed out at you from this?
For me, it was, multiplication, fractions, so mixed numbers, mixed numbers, and time, so measure.
Yes. So how did you solve the problem? Let us know what was your method.
That's my question to you, isn't it?
Oh, yes, I know. I'm trying to get away with ask me the question.
So
how did you calculator?
Did you use a calculator straight in?
Yes. Well, I will now do it the authorized way for year 7.
Well, but I think it's interesting. So with your calculator, did you use a scientific one?
I used one on my computer.
Okay, and how did you do it on your computer? Because I'm interested to know what you did for 2/3.
Oh, I did it as 2 separate bits. I did 58. Although afterwards I realized, this is an easy number to do. I did 58 times the 24, then the 2/3 times the 24. But then I realized, actually, I can do one bit of it really easily. It doesn't need...
I'm asking the calculator thing because I think some people might not know how to do fractions on the calculators.
Oh, yes, because to be honest, you press 58, then there's like an A, B, C fraction thing. You press 58, that fraction button, then 2, then the fraction button, then third. So it's actually not very intuitive unless you've seen it before.
Yeah. So
then you times that by 24.
So you did it as a 58 2/3 on your calculator and then multiply by 24. And then how would you have done it without your calculator? You don't have to go into the details.
Yeah, so just 58 times 24. I know there's something called a grid method for multiplication. I just use the standard column method. Although kids are now, they talk column now rather than grid again. It goes in cycles. It'll come back. When you listen to this podcast in like 10 years, it'll be like, oh, they've got the three-dimensional orthogonal method of solving it, but who knows? And then the 2/3 times 24, actually, that one you can do as arithmetic because you split up the 24 into three parts of 8 and 8, and then you need two of those parts of 16. So you can add that onto the product of 58 and 24.
Brilliant. Okay. So because I knew we were going to go through this, I suddenly thought, is there another way of doing it without like doing column method or grid method? And I was like, okay, what do we know with these numbers? So 24 I kept, and then that's what we're multiplying by 58 and 2/3. So then I thought, how can I split 58 up into easy ways of doing things?
Oh,
So I thought, let's do it. So I was thinking about doing it kind of without the standard method. So I did 24, which is what we start with, to multiply by. So I did 50, then by 8, which I'm going to add to it, and then by 2/3. So I'm doing it in parts. So 24 times 50. So the way I do that quickly, I do 24 times 100, which is 2,400, then half it to get 50. So 1,200. So that's put that in the bank, 1,200 in the bank. So then to multiply something by 8, you double it again, that's times by 4, then double it again, that's times by 8. So then 24 gives you 48, so doubled, that's times 2. Times by 2 again gives you 96, then multiplied by 2 gives you 192.
Lovely,
put that in the bank. In the bank.
Very nice.
And then 2/3, you find 1/3, which is 24 divided by 3, which is 8. And then 2/3 times that by 2, which is 16. Then I add them all together.
To give us 1,408 hours. And you also learned that a day in Mercury. Never tell someone, I'll give it to you I'll give it to you tomorrow.
If you're on Mercury, you mean?
Yeah, it will take 1,408 hours.
We should think about what would be mad is if to think about all the different other planets you could work out, which ones move quicker than others. I don't know. My general science, my cosmic knowledge is not that great, but I'd love to know more. So then we'd love to, as you say, as always, we'd love to hear what your solutions are. We're going to share how Bobby and I did our solutions. We're going to show the visuals of that, post it on Twitter and Instagram. And as always, we'd love to hear from you to share your ideas as well. And as always, we finish with Bobby telling us a maths fact.
So we're going to stay on the theme of astronomy. So Susan, a question to you first. Okay. How are planets, or how have they been discovered in our solar system?
I don't know. People look at them from the telescopes?
Yeah, quite literally. So initially, some antiquity, there's Mars. I can see it looks like a little star. But it can't be a star because it seems to be rotating around the same parallel or plane as us and the sun. So initially just looking it up. So you just observe it, eyes or then telescope. But in our solar system, did you know there was a planet that was discovered just using maths?
What?
Just using maths. It's bonkers. So this sounds insane because it is a little bit insane. So the planet Neptune was actually predicted by maths to exist before they saw it.
Wow. So before they saw the planet, someone had said there's something in that space, in that region.
Yes.
And then So
we go back to 1781 initially. So there's a brother and sister cool duo called William and Caroline Herschel. And they actually had a homemade telescope and they found Uranus. That's how you pronounce it. I don't want anyone... Sorry, Susan's laughing now. Uranus. Badly named planet, man. Anyway. So
I'm an adult.
Yeah, I know. By the mid-1840s, about 1847, Uranus had actually made a full orbit around the sun. Right. And by that stage, they had lots of data. And what the data, or the numbers, showed was there's a discrepancy in Uranus's path around the sun. Because according to Newton's law of gravitation, it should follow a particular path. But the data showed or indicated that there should be something massive beyond Uranus. I know, there's all so much innuendo that had affected the course of that planet's orbit. And they're like, actually, there must be something beyond that. So later they actually found that discrepancy was Neptune's gravity pulling on the planet Uranus.
Oh, wow. So they were like, something's not quite right. So we think there's something in the way. And then they put that... How long did it take before they were they had made a prediction? And when did they actually see it for the first time?
So I think it's in the same decade, but...
Wow.
Yeah, but it's impressive that... So there's a French mathematician, astronomer, called Leverrier and a British astronomer, John Couch Adams. They independently both said, oh, there must be Neptune. I think it's a pretty astonishing fact.
I think it's amazing. Thank you, Bobby, always for extending our minds.
Obviously, if you get any more facts or problems, please get in touch. We're at MathsAppeal on Twitter and Instagram.
And we're also on the amazing email. So email us at mathsappeal1
And we really appreciate you downloading this episode of Maths Appeal. And we'd be incredibly grateful if you give us a 5-star rating or tell your friends or spread the word. Those things really do make a difference.
So you've been listening to Maths Appeal with Susan Okereke and Bobby Seagull.
The music's composed by Kelly Okereke. The image design is by Calix Davis. And our wonderful producer is Jenny Nelson. So we'll see you for our next episode where we're going to solve more math problems. And we have the incredible guest, stand-up mathematician Matt Parker. So don't miss out.